Carly.
Welcome back to my channel.
Bing. I thought she was ready. She totally wasn't ready. Okay, so last time we reviewed and tested for Unit 7, which was logs and exponents, and today we get to talk about statistics. I'm excited to talk about statistics because the other thing that I teach is AP stats. You can go ahead. It doesn't bother me. So I think that this stuff is really interesting. Carly's all worried because it's a whole bunch of words. But I promise you it's not that bad. So today we're going to probably get to these 2 pages. But I also brought around a supplementary paper that we need to help us with our quiz. So, statistics all center around collecting data. So the basic framework for statistics is this process right here. So we want to identify something that we're interested in about a population. So for instance, I personally am interested in whether or not listening to music truly makes you do better on a test or on your homework. Does that make sense? Like lots of kids will say, well, I do better if I listen to music. And I think that it would be interesting to see if that's really true. So then the next step would be for me to decide who I want to know that about. So I want to know that about you guys. I want to know that about high school students. But it's probably not going to be feasible or practical for me to talk to even every student at Cypress High, especially now during COVID. It would be really hard for me to track down every single kid and look at whether or not music truly helps them. So instead, I take a sample. I'm going to take a sample of students that go here. So instead of having to talk to like 3,000 kids, I'm going to choose to only talk to like 50 kids. So once I choose my sample, I collect the data. So there's a few different things that I could do to collect data. Then I organize the data that I collected, and then I interpret and make a conclusion. So today we are focusing on we may get to the first 3. So the first 3 is what we'll end up talking about. So before we can even collect data or talk about the different types of methods for collecting data, we really need to make sure that we're very clear on what a population is and what a sample is. So that's where we're starting. And that's that little paper that I brought you. So first one says a population is the entire group of individuals that you want information about. I just need to find my pen. A population is the entire group of individuals you want information about. So if I want to know if music truly helps you guys do better on work, my population would be every single student that goes to Cypress High. I'm missing a paper. A sample is a group of individuals in the population from which we actually collect data. So a sample is a group within the population from which we actually collect data. So population is everyone. Sample is a group of people from the population we're interested in. So in my music example, the population would be, let's just say 3,000 students go here. So the 3,000 students at Cypress High, My sample would be the 50 kids that I select to actually figure out if music helps them learn. So the whole point of basically this entire extra little packet that I brought you is so that we can clearly identify the population and the sample, because half of your quiz questions are having you do that. So a state education official is interested in the number of years of experience that teachers have in his or her state. Using Social Security numbers, the education official generates a random sample of 1,000 teachers and determines their years of experience. So I know that this is the sample because it tells me that. So that's the first one that I can fill in. What is my sample? Let's be really specific. 1,000 teachers. 1,000 teachers. So what's my population then? Well, the person that's interested in this is a state education official, and they are interested in the number of years of experience that teachers have in his or her state. So teachers in his or her state, which means that your population is all teachers in the state. So every single teacher in the state. We're going to randomly select 1,000 of those teachers. So I'm pretty sure in our district we have 15,000 teachers. That might be too many. We have thousands of teachers in this district. So there are probably like 50,000 teachers in our state. So what are we interested in? This last question, the sample statistic, is what we want to know about these people. So in this case, we wanted to know their years of experience. We wanted to know their years of experience. So population, all teachers in the state. Sample, the 1,000 teachers that we actually gathered the ages of. And what we were interested in was years of experience. Okay, 2. An airline company wants to know if passengers are satisfied with the in-flight movies on its international flights. The company decides to conduct a survey by randomly selecting 200 passengers and asking those passengers to fill out a simple questionnaire. That end part you can just ignore. So, the sample is easy to find. We're randomly selecting 200 passengers. So our sample is 200 passengers. So to find out what our population of interest is, we usually want to think about who is interested in this information. So it says an airline company wants to know if the passengers are satisfied with the in-flight movies on its international flights. So we know that our population is going to be passengers because that's what our sample is, but we need to be specific, so the population would be all international passengers. So airlines have 2 different kinds of passengers. They have domestic, so that means you fly, like for us, you would fly anywhere in the United States. International means you're going to other countries. So they're going to have 2 kinds of passengers. They're going to have domestic and international. but we only care about the international passengers because that's what they tell us we care about. Is that making a little bit of sense? We don't want to include other passengers because we don't care what they think about the movies. The sample statistic is, let's say the percent satisfied with movies. So I'm kind of writing that as shorthand so that you don't have to write a bunch of things down. So our population, all international passengers. Our sample, the 200 that we actually have fill out a survey. What do we want to know from that sample? Whether they're satisfied with the movies. And we'll calculate the percent that are satisfied. Okay, example 3. New York City wanted to determine the amount of training its doctors and nurses have received since they started working. To do this, they decided to conduct a survey of 200 randomly chosen doctors and nurses who work in New York City. So sample 200 doctors and nurses who work in NYC. So our sample is specifically doctors and nurses who work in New York City because our population is all doctors and nurses, but only in New York City. Because New York City is who wanted to determine the amount of training. This time, the sample statistic can be two different things. So one thing that we might be interested in terms of training is how many hours of training they have done. How many hours of training. Or we might be interested in the number of classes, training classes they've taken. And we could want to know other things about training besides that, but that's two examples of what we might be interested in, what our sample statistic might be. Okay, example 4, let's have you guys try the population and sample, and I will do the sample statistic with you. So you guys list the population and the sample, then I will do the sample statistic with you. We'll do one walkthrough and then we'll check in. Okay, about 20. $10. About 5. Okay, population is all pitchers in the league, in their specific league. Sample is the 30 pitchers that they selected. The sample statistic this time, they gave it to you, and it's an average. So when we have an average, we call that X bar. When we have an average, we call that X bar. And we found that to be 68.5 miles per hour. So in this case, we actually have a value for our sample statistic. Okay. Example 5. Okay, you can do population and sample on this one too. We will do sample statistic together. So you are identifying population and sample. We'll do statistic together. We'll go about 20. $10. $3. Okay, so population is all city residents. Your sample is the 1,000 city residents that were selected. So all city residents, 1,000. Okay, so 823, oh, I see the issue here. 823 residents respond to the survey, and 697 report they are satisfied with the city's transportation system. So this one actually is a little tricky. Our sample size isn't really 1,000. What is it really? Yes, I heard 623. Hugo is right. It's the 823 that actually responded. So we send out 1,000 surveys, but our sample is really only those that responded to the survey. So the 1,000 we don't need to write anywhere. What is our sample statistic? Well, the mayor wants to know the percentage of city residents that are satisfied with the transportation system. So when the sample statistic is a percentage, which is also referred to as a proportion, we call that P hat. It's P with a little triangle on the top, like a dunce cap. P hat. And we can actually calculate the sample statistic. So, out of 823 respondents, 697 said that they were satisfied. So in your quiz, it's going to have you, I think you can leave it as a fraction, but let's change ours to a decimal just in case we need to. So we would do 697 divided by 823, and that would give us 85%. So we're going to round to 2 decimal places. This guy would be 0.85. So I'm going to write that as 0.85. So our sample statistic is that 85% are satisfied with the city's transportation. Okay, you try all of 6. Okay, roughly 30. About 10. Okay, so population is all households. Make sure that you use the word households. All households in this particular large city. So it's specific to this city. Our sample is 50 households. Our sample statistic was the average amount of money spent each week. So that was an X bar. And it was the average, you don't have to write this down if you don't want to, amount of money. Okay, there are a total of 1,200 students at Tyler's school. Tyler randomly selected 150 students at his school and asked them how many languages they speak. The results of this survey indicate that 28% of students speak 2 or more languages. Okay, so sample is always the easiest one for me to identify, so that's going to be the 150 students at his school. Now, the other number that they gave us, we have to ask ourselves, is that the population? So they say there is a total of 1,200 students at his school. Because they use this word total, that indicates to me that that's the population. So our population is the 1,200 students at Tyler's school. So this is the first time they actually give us the size of the population. Population is 1,200. Sample is 150. The results of his survey indicate that 28% speak more than 2 languages. Since this is a percent, our sample statistic is a proportion. So you'll see it referred to as a proportion, which is P hat. He's that new guy, that P with a hat on. Okay, I ran out of storage so my recording stopped. The last thing we checked in on was the proportion of students at Tyler's school that could speak more than 2 languages. So in class, they're doing example 8 all on their own, and we're going to check in just a minute. Okay, so our population is 1,000 students at this school. I want to try to be as specific as possible. My sample was 50 students. Give the sample statistic for the proportion of students who are studying art. So this is going to be a P hat. Well, out of 50 students, how many of them were studying art? 12. We plug that into our calculator or Desmos or whatever you use, and I'm pretty sure that that's 0.24, which is 24%. You can just leave it as a decimal. So 0.24 or 24%. You're hanging in? Okay, we're almost done with this part of the lesson. Okay, I'm just double checking. Let's take like 3-ish minutes and have you do as much of this last page as you can. So if you're at home, pause the video and you try 9, 10, and even look at the bonus one, because I think you could do parts of the bonus one. So pause the video, try it, and then unpause so that you can see the answers. Okay, example 9 is all people who live in this town. The sample was 400 residents, and the sample statistic, so the proportion, was 0.17 or 70%. Just kidding, 17%. The beverage company is all students of this high school. 40 students of the high school was the sample. The proportion of students that preferred a soft drink was 30%. Then the last problem.
The water was 12, soft drink was 18.
Oh, did I read it wrong? No, found that 18 preferred water, 12 preferred a soft drink, and 10 preferred juice. So I'm pretty sure that's 12 out of 40. Okay, the bonus example requires you to find the sample statistic. So your population is the 21,360 books at this library. The sample is 80. What is the best estimate for the amount of historical books? Well, the first thing that we have to do is find the percent of books that are historical. So out of the 80 that she looked at, 6 were historical. So we're going to change that to a percent. 6 divided by 80 gives us 0.075. So that's 7.5%. If we times this number by 100, we get 7.5%. So that means 7.5% of this 21,000 books is probably historical. So to find the answer to this guy, I'm going to take 21360 and I'm going to multiply it by that percent that we just found, and we're going to use the decimal. So 21360 times 0.075, I got 1602. Is that an option? Okay. So B. Okay, so this whole thing has to do with the first 2 boxes on this page in our notebook. What might we want to know? What is the population? What is the sample? So what might we want to know was years of experience, population, all teachers, sample 1,000 teachers. So the last thing that we're talking about today is how we collect the data. Now that we know what we're interested in and who our population and sample will be, how do we collect this data? So I'm going to circle that box because this box is what this page has to do with. So there's 4 different things that we could do. The first one is an experiment. So I'll read you the box and then I'll give you a concrete example. An experiment imposes a treatment on individuals in order to collect data on their response to the treatment. The treatment could be a medical treatment, it could be an action that would affect a variable, it could be something like adding methylene or methanol to gasoline and seeing if that reduces your fuel efficiency. But at the end of the day, the biggest distinguishing factor about an experiment is that you control something. So I'm going to write in parentheses, I control what you do. If I'm going to run an experiment, I'm going to control what you guys do in my sample. Now that's almost the complete opposite of what the next method is, which is an observational study. An observational study observes without controlling. Observes without controlling. So if I'm in charge of this observational study, I watch what you do. I watch what you do. So examples of that could be sitting outside of the bathroom and counting the amount of people that wash their hands before they leave. So like at Granger, you go into the bathroom, but when you come out of the bathroom, it's a common area that's in the hallway, and that's where you wash your hands. Like the sinks aren't in the bathrooms. So you could sit there and watch and count up how many people wash their hands when they're done. And now it's probably 100%, but a year and a half ago it was probably like 42%. Probably not that high. Okay, then the last kind is a survey. So a survey is an investigation of one or more things that you're interested in, but in this case, you just ask questions. So every member in the sample is asked one or more questions. So in this case, if you're writing these down, I control what you do, I watch what you do. This one would just be I ask questions. Okay, so let me give it to you in terms of the listening to music while you work example. So if I wanted to investigate whether or not you guys truly do better when you listen to music, a sample survey would be if I just asked you, do you think you do better when you listen to music? And then you tell me yes or no. Does that make sense? Are you sure? An observational study would mean I tell you guys, hey, I'm interested in knowing if the music helps you, so if you want to listen to music while you work, you can. I let you guys decide. I watch those of you that listen to music, and I compare your scores to the kids that did not. Does this make sense? So I just watch who does and doesn't, and then compare your scores. The first one, I ask you. An experiment, though, would be me coming in and saying, okay, this half of the room, you have to listen to music while you work, and this half of the room, no music. And then I compare your scores. So I'm controlling who listens to the music and who doesn't. So on the next page, oh wait, there's one more, my bad. This one, I forgot about him because he doesn't necessarily fit in with the rest. So a simulation uses a model. A simulation uses a model to reproduce the conditions in a situation or a process so that the simulated outcomes closely match the real world outcomes. So simulations allow you to study situations that are impractical or dangerous to create in real life. So I don't know if you guys even see these, we saw them at my age, but I don't know if they still exist, but like the videos of the crash test dummy dolls, where the crash test dummies are in the car and then they smash the car into the wall and see how much damage the dummy has. That's a simulation. So maybe I'll write a note there that the crash test dummies would be an example of a simulation. We would not want to randomly select a few people to go crash the car and see how much damage it did. Okay, so then next page gives you several opportunities to decide if it's one of these four things. So it's either an experiment, observational study, survey, or a simulation. You cannot just say study. You have to include the word observational. So you label them. Do you know what you're doing? Okay, let's take like 2 minutes. Once again, if you're at home, pause the video, do the page, unpause, check in for answers. Okay, A, a researcher records whether people at a gas station use hand sanitizer. Observational study. OS. All we're doing is watching. I would be writing them out if we weren't checking answers. Like I would write out the actual words if I didn't want you to wait for me forever. A landscaper fertilizes 20 lawns and with regular fertilizer and one with organic and then compares. That's an experiment. He's actually doing something to the lawns. Members of a student council at your school ask every 5th student. That's a survey. A park ranger measures and records the heights of trees in the park as they grow. What do you guys think that one is? Oh, so good. Researcher uses a computer program to help determine how fast an influenza virus might spread. Simulation. Because we wouldn't want to intentionally spread the flu to people. Know what I'm saying? We might check rats, maybe. But in this case, we're using a computer program. A group of mice are put into a maze with multiple paths and options, the time it takes each mouse to complete the maze, and the path taken are recorded. Observational study. To be an experiment, you would need to blindfold the mice. Or maybe inject them with some alcohol and see if they're drunk driving. Carly? A group of mice are given an oh, okay. That's an experiment. Now we're messing with the mice. We're going to inject them. And lastly, a group of students are randomly selected and asked whether they study with music on. Survey. Survey says. What? Oh, okay. Do your quiz. Do it.